Okay, hello everybody. Welcome to another episode, another video on my channel. There's no episodes. I don't have a single series that is actually ongoing right now. Welcome to another video on my channel. Today, I'm going to talk about why I am the best programmer and the Boyer-Moore algorithm. And you know, for that, I've actually created a beautiful PowerPoint presentation for all of you. So let me actually just start this up and really show you what we're going to talk about today. All right. Today we're going to talk about, again, why I am the best programmer and the Boyer-Moore algorithm. The contents of today's video is why I am the best programmer and the Boyer-Moore algorithm. First of all, why me? Why am I the best programmer ever? Okay, we're going to start off with that in this presentation. Well, it's because there was a competition, a computer science competition in the last few months, the Germany's official competition, and I actually won that competition, yes. To be fair, I got into the second round, but that's basically the same thing. Just ignore that. Ignore this right here. It's the same thing, okay? It was really just too easy for me. No sweat at all. Here is actually also some visual proof. If you look towards your left, you can see the three tasks that I completed. Me and my team, we did 4 tasks, and I completed 3 because I am simply the best programmer. And looking to your left, looking to your right, you can see that I got 3 out of 5, 4 out of 5, and 5 out of 5 points, and especially the last one was very impressive. Easy, simply easy. A quote by myself, yes, to visualize how good of a programmer I am, to really drive it home, to drive this point home, to make it really, you know, make you really understand that. You can see this comparison here, this diagram, which, you know, just makes it so much more imaginable, right? Tangible, this whole concept. And especially tasks number 1, beautiful, perfect, impressive. Whoa, oh my god, 5 out of 5 points. How did I do that? How I did it? The Boyer-Moore algorithm. So without further ado, I'm going to show you now, losers, what this task is all about, what task number 1 of the Bundeswettbewerb Informatik was all about, and how to solve it with the Boyer-Moore algorithm. So let's take a look at this this task. It's in German, so I have to translate. Störung. It's called Störung. No, it's not called Störung or whatever the hell, you stupid English people. It's called Störung. Yes. Okay. So basically, it's about 2 children. God damn it, children again. Alice and Bob, and they're reading or they like the book Alice in Wonderland. It's their in Wonderland. It's their favorite book. And wait, actually no, I have to read the sentence myself. Well, hold up a second here. Okay, I think I've got it like half. Now, look, the essence of this task is known to me, but that's not the point. Look, it's about Alice and Bob, and for some reason, these 2 children who have not received enough love, seemingly, from their parents, they like to exchange quotes from Alice in Wonderland, and there's another person called Trudy, I don't know, and somehow he always sends quotes that are that are like this, you know, that are incomplete and that have a few words in between them that are just that you just can't even make out. And so as when Bob got that quote, he had to search for the quote. Like, he had to go through the entire book and search for that quote. And after like years and years of searching, he finally found this sentence, which fits with this pattern, I guess. Because the first word is das, the second word is something. So in this case, it's kommt. And then the next word is mir, and then, you know, 3 words, 3 random words, and then vor as last word. And he is unsure because, you know, he thinks, okay, maybe there are other quotes in this book that fit with this pattern. So, you know, Theoretically, he'll have to go through the entire book and check everything, but that's not absolutely not doable. Nobody does that. I mean, it's like taking a look at the fact that Alice and Bob seemingly do not have enough hobbies. They seemingly do not have enough interests in life, and they're so incredibly bored that they're exchanging quotations. I would actually assume that they would have enough time to do this, but whatever. For the sake of this task, for the sake of not misunderstanding anything, we have to basically write a code that can take a pattern and take the script for the entirety of the of Alice in Wonderland, and then basically find every single I don't know, every single quote that fits with this pattern. That's basically the idea. So okay, let's begin. Let's start with the simple algorithm. Let's start with just straight up brute force. Okay. Oh God, what's happening? Why can't I write? Man, it's not working. Here we go. Okay. Brute force. How does the Bruce Lee algorithm work? You know what? No, this is enough. No. How does the Bruce Lee algorithm work? The Bruce Lee algorithm works as follows. You have a certain pattern, right? And we have a certain text, something like that. Then what you would do in this algorithm is you would just put this pattern down here, A, B, C, blah, blah, D, and then you would go through each and every character. We'll start off here, and in programming you always start off with the index 0, and you'll see, oh look, A and A, it's correct. Nothing's wrong here, and both characters are the same. So then we can move on to the next index 2, or no, index 1, I'm stupid. And as you can see, oh no, it's not the same character. What will I do? My parents will disown me. And so what you will do is you'll notice that this alignment, this entire alignment with an offset of office, okay, well, I guess it's an office now instead of an offset, with an office of 0, is obviously not going to fit anymore. It's not correct. That's not in the text. In the text, there's no. It's not a substring. This substring does not. It's not. It doesn't. I don't know how to communicate this. It's not the same pattern, right? It's not the same thing. And so let me just delete everything that I just wrote here. So what you would do is you would notice, okay, this offset does not work. So let's offset it by 1. So plus 1. Offset is going to be incremented. So let's just take this entire thing, and then offset it by 1, right? And then we do the same thing again. And then we go, it's the exact same procedure. It's the same character. Good, my parents won't disown me. Oh, it's also the same character. Look, my parents actually love me now. And oh no, oh God. My parents burned it in a fire. I don't know. Right? Something like that. And so we'll keep on going. We'll repeat the same procedure over and over again with little regard to, as for other indicators that may tell one that this wouldn't make sense, this alignment. We just keep on going, right? Same thing here. Doesn't work. Parents disowned. Or you're disowned by your parents. Same thing here. Parents disowned because, well, doesn't work. What the hell, right? It doesn't. No, it just doesn't. The pattern doesn't exist here. So we then just keep on going, keep on getting disowned by our parents until we find finally some enlightenment, right? We find an offset. What is this? This is offset 0, 1, 2, 3, 4, 5, right? This is the current offset. I wrote offset again, which is absolutely great. Offset, like that. And we go, oh look, A and A, same. B and B, same character as well. C and C, same character as well. And here it's a special case because we have, in this task we have wildcard characters, I like to call them, like just or wildcard words, and I guess that that can match with any other word, any other character, and so that would be valid as well. This is the same thing as well. It's also valid, and D&D, that's correct as well. And suddenly you got something, and now you can return this whole substring along with the offset, and you've got yourself one a match, I guess, that you can save in a list, I guess, of matches, and towards the end of the algorithm, you will tell the program, okay, these are the matches that we found within the script of Alice in Wonderland, right? That would be the idea of the brute force algorithm. Now, of course, as I've just hinted at before, it's obviously not fully the same thing. Currently, we're using characters to represent the words, but it's not really that big of a deal because then we just, well, replace characters with words. You know, it's not that big of a deal, really. So yeah, that was it. That's a Bruce Lee algorithm. Okay, so let's move forward with the Boyer-Moore algorithm. Boyer-Moore, wow. But honestly, instead of it being the Boyer-Moore algorithm, really what I'm going to talk about today is the bad character rule. Bad character rule. There are two parts to the Boyer-Moore algorithm. One of them is the bad character rule, which allows you to skip a lot of things, a lot of alignments, right? Oh god, I just deleted everything. But the second rule, there's also a second rule called the good suffix rule. But we're not going to talk about that today. That's because I don't have any time, and it's definitely not because I didn't know how to actually implement it. I'm just stupid. Okay, let's talk about the bad character rule then. I'm going to use an example from Geeks for Geeks. I know it's a little lazy, but I'm just not. I just don't care enough. I couldn't. No, like just no. Okay, I'm just gonna copy it off from Geeks for Geeks from that website. This is great. That's basically, here's the pattern. Pattern P. We're gonna call it P, and then we've got the text in and of itself. It's T, capital T. And this, in our case, would be the script of Alice in Wonderland, and the pattern P would be the stupid quotes they were exchanging. How old are these children? Jesus Christ. I should stop bullying them. Like, I'm going to get cancelled for this, because we should always accept everybody and their interests. We shall never discriminate. Which is true. Like, look, I'm not gonna, I'm not gonna discriminate. I'm not gonna bully you because of your interest. Like, come on, I'm the biggest nerd ever. I'm the one who deserves to be bullied. Okay, so none of that. Anyways, let's actually talk about the Boyer-Moore. Yeah, well, whatever. Boyer-Moore. The Boyer-Moore algorithm. Now, okay, it's the Boyer-Moore algorithm. The actual now. So basically, what Boyer-Moore does in the bad character rule, at least, it starts off from the front instead of back here, right? It starts off here, right? And so we can see, okay, we have two characters that are equal, that's fine, or two words in our case that are equal. Two G's, that's also fine. And suddenly, oh no, again, we get disowned, even by our goddamn dogs. Because A and G, they're not equal. Not all characters are made equal, and that's kind of sad. This is so sad. And can we get an F in the chat, boys? Right? Something like that. So what we'll do at this point is, if this character in T appears in our pattern P once more, from this point on, I guess, right? Then we'll jump so that this character, this A, will align with this other A. You see what I'm talking about here? These two A's. So we'll jump like that. That's basically how it works. Instead of going through every other alignment or every alignment, we'll just think about it and just be intelligent about it and actually jump to a certain alignment that will guarantee at least that this A will align with the other A that is here, because unless that happens, there's definitely not going to be an alignment that results in a match. That's basically the idea behind it all. Now, but what if we have a certain or a certain character that just doesn't appear in this pattern P anymore? So let's have another example here. Same example, also from not Elite Code, Geek for Geeks. Let's see here. Copy off the entire thing again. And let me just get rid of this. Yes. And we've got alignment at index equals 2, AT, GT, and then G. And you'll see here we will get disowned by our grandparents after having been left by our parents after realizing that C and G are not the same characters. And there's another problem, and we will get disowned by, I don't know, our uncle as well. Because C doesn't even appear in this pattern. This is so sad. Can we get a double F in the chat, boys? Anyways, this is obviously a problem. Actually not. It's not a problem. It's a big W in this case. Because what we can do is we can take this entire pattern and just go whoop! Just jump. You know, just take it and just yeah, yeet. Just jump completely. Now, why is that? Why is that the case? Well, take a look at it. The previous pattern, the previous alignment where it was is looked like this. C did not appear in this entire pattern. So even if we trot out every alignment from this point on, there will be no alignment that will result in a match. So we can just simply be smart about it and just jump the entire way. And in this case, it actually results in a match. It's crazy, right? These two characters fit, these two characters fit, these two characters fit, these two characters fit, and so on. You know what I mean. You're not stupid. And so we can take this entire substring from T again, right? Take the alignment 8, put it in a certain list. That's a great way of depicting it. And towards the end of the algorithm, again, after iterating through every alignment, again, in this case, not actually iterating through every alignment, but every alignment that makes sense, intelligently jumping in a way from alignment to alignment. After going through the entire string, at the end we can return that list and, you know, just be happy about it. And those two stupid children, they will finally be at peace and come to terms with the fact that their parents do not love them and that they have to love themselves. Yeah. Yep, that's the Boyer-Moore algorithm.